Hello students, welcome back to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are going to do top 30 PYQs from the chapter Thermodynamics, okay? So after watching this video, you will be able to solve all the questions that is being asked in KCET from Thermodynamics chapter. I can assure you that. So pause the question, like see the video, pause near the question, solve it and then check the solutions and try to score yourself and comment down your scores, okay? You can join our WhatsApp channel, link is there in the description section. This will help you to get access to our PDF notes and your mock test solutions, etc. Okay, so let's start with the first question here. Okay, so if you see 5 moles of a gas are put through a series of changes as shown graphically in a cyclic process. A to B, B to C and C to A respectively. So if you see in A to B, okay, A to B volume is constant, right? That type of process are called as isochoric. Okay, so we have only 2 options with isochoric, we can eliminate these 2 options. Next, if you see B to C, so in B to C you can see if pressure is also changing, volume is also changing, that means temperature will be constant. If temperature is constant, then it is isothermal, right? So here we have isothermal. Next we have C to A. So C to A, sorry, one second. Here I did a mistake, one second. Okay, so now what I was saying is B to C, if you check, see, in B to C, temperature is changing, volume is also changing, that means pressure is constant. So if it is pressure is constant, it is isobaric, okay? And next C to A, temperature is constant, right? So it is isothermal. So the correct answer for this question will be option number A, okay? Next is question number 2. For an adiabatic change in a system, the condition which is applicable will be. So adiabatic change, heat will be 0, Q is equal to 0. Option number D is the correct answer. Next here, the work done when 2 moles of an ideal gas expands reversibly and isothermally from a volume of 1 liter to 10 liter at 300 Kelvin is. R value is given to you. So we can use isothermal reversible process. Work done is minus 2.303 nRT log of V2 minus V1. Right? Now if I want to substitute here, that will be equal to minus 2.303, N is how much? 2 moles, okay, R is 0.0083, okay, then okay, here you have to see, here it is kilojoule, right? So we'll get, so I'll write the unit so that we can check. One second, let me solve this question on this side where I have more space. So I can put work is equal to minus 2.303 into N is 2 moles, okay, and R is 0.0083 kilojoule Kelvin mole inverse, okay, and temperature is how much? Temperature is your 300 Kelvin, okay, 300 Kelvin log of V2 by V1, so 10 by 1, okay, so that means log 10. So now if I want to solve here, it is minus 2.303 into 2 into, now here you can see Kelvin, kilojoule, Kelvin, so this was Kelvin inverse, right? So Kelvin inverse will get cancelled, mole inverse will get cancelled, we will be left with 2.303 into 2 into 0.0083 into 300, okay. So now if you solve this, you will be getting around 11.5, so correct answer is option number C here, okay. You can check, solve and check this one. Next question number 4, what is the work done? Okay, one more thing, okay. Next question number 4, what is the work done when 1 mole of a gas expands isothermally from 25 liter to 250 liter at a constant pressure of 1 atm and a temperature of 300 Kelvin. So again we can use isothermal process, work done formula, W equal to minus 2.303, okay, number of moles is 1, okay, R you can put 8.314, okay. Next we have okay, 8.314, then we have temperature is 300 Kelvin, okay, so nRT log of V2 by V1, so that is 250 by 25, okay, so that is again log 10, so that is equal to 1, so we can just calculate minus 2.303 into 1 is there, so we can leave that. 8.314 into 300. Okay, so you can see you'll be getting around something 5000 if I multiply here, right? So yeah, so that is around this one. So correct answer is option number C. Okay, next is question number, so here, yeah, next is question number 5. 1 mole of a perfect gas expands isothermally and reversibly from 10 decimeter cube to 20 decimeter cube at 300 Kelvin. Delta U, Q and work done in the process are. Okay, so now here you can see important thing. For isothermal process, delta U is always 0. Okay, so that is why we can have 0 here. Okay, now delta U, okay, is equal to Q plus W. Okay, if this one is 0, I will get Q plus W. I can write Q is equal to minus W, right? Or I can write W is equal to minus Q, right? So what the conclusion here is, W and Q sign should be different. One should be positive, one should be negative. With that only you can solve this question. You can see here, and the values should be same, right? You can see here the values are different. We can eliminate this option. Here also you can see the values are same, but they are also same sign. In that way also you can eliminate. Now if you see here the values are same, signs are opposite, then definitely this has to be the answer. You do not have to solve this question at all. Okay, but yes, again if you want to calculate the work done, you have to do the same formula. Minus 2.303, N is 1, R is 8.3 into 10 to the power of minus 3, temperature is 300, and log of V2 minus V1, so 20 by 10. Okay, so that is log 2. Clear? Next, question number 6. Based on the first law of thermodynamics, which one of the following is correct? Okay, now if you see, the first law of thermodynamics tells you that delta U is equal to Q plus W. Okay, one more thing I want to tell you, you might see that here there is Comet K previous year questions. Okay, so if you thermodynamics is a chapter of PU1 and it has very less weightage in the KCET. So if you see last 10 years of question papers, you will get hardly 10 or 11 questions. So to make this top 30 questions, I have added some questions from Comet K also. Okay, so the level are almost equal. So Comet K questions also you can practice. Comet K and KCET questions are there in this particular video. Okay, and now if you see which of the following is correct. Okay, for isochoric process, work done is 0. Okay, isochoric means what? Volume is constant, right? And what is the work formula? Minus P dV, right? If volume is constant, dV is equal to 0, that means work will also be equal to 0. So delta U will be equal to Q, but it is given minus Q, right? So that is why this is not correct. For an adiabatic process, what happens? Q is equal to 0, means delta U will be equal to W, but it is again given minus W, so that is also wrong. For an isothermal process, delta U is equal to 0, so Q will be equal to minus W, but it is given plus W, so that is also incorrect. Now for a cyclic process also, delta U is equal to 0, that means Q will be equal to minus W, so option number D is the correct answer here. Okay. Next, question number 7. When 2 moles of C2H6 are completely burnt, 3129 kilojoule of heat is liberated. Okay. If delta H for CO2 and H2 are 395 and 286 per mole respectively, then the heat of formation of C2H6 is. Okay. Now if you see this question, okay, when 2 moles of ethane are burnt, so we'll write the equation like this: 2 moles of ethane, okay, plus O2 will give you CO2 plus CO2 plus H2O. Okay, now if you have 2 moles, so that means it is making 4 carbon, so I can write 4 CO2 here, and here it is 12 hydrogen, so I can write 6, right? So now I'll get 14 here, and here this is 7 by 2 O2, 7 O2, right? This is the balanced equation. Now the heat liberated in this process is 3129 kilojoule. Okay, so heat liberated, or the heat of this reaction, what will be the formula? That will be equal to the enthalpy of formation of products. So that is, I'll write like this. You see there are 4 CO2, right? 4 times of the enthalpy of formation of CO2, okay, plus 6 times of the enthalpy of formation of H2O, right, minus O2 is an element found in the native state, right? It's the pure state. So delta H formation of O2 is 0, right? And 2 times of delta H of C2H6. Okay, now I can substitute the values here. What is the delta H of the reaction? That is 3129 kilojoule. Okay, and then we have 4 times of CO2, that is minus 395. Okay, plus 6 times of H2O, that is minus 286. Okay, minus we have 2 times of delta HF C2H6. Okay, so now if you solve this and divide this one, you will find that the delta HF value will be something around minus 83.5. The correct answer here will be option number B. Okay, you can check the calculation, you will get it. Next, question number 8. Given reaction NH3 plus 3Cl2 give NCl3 plus HCl minus delta H1, N2 plus 3H2 gives 2NH3 minus delta H2, H2 plus Cl2 gives 2HCl plus delta H3. The heat of formation of NCl3 in the terms of H1, H2 and H3. Now see, the heat of formation of NCl3 is asked, right? That means you are forming 1 mole of NCl3. So what is the equation for that? That is what you should write first. So if I want to form 1 mole of NCl3, right, heat of formation means the reactant should be in their elemental state, right? So I will write half N2, okay, nitrogen should be half molecule, and 3/2 of Cl2, right? This two if I add, I will get NCl3. Now I have to derive this from the given equation. Now if I see what are the given equations, we have NH3, okay, plus 3Cl2, okay, that is giving me NCl3 plus 3HCl. Okay, next we have N2 plus 3H2, okay, and that is giving you 2NH3. Okay, next we have H2 plus Cl2, okay, and that is giving me 2HCl. Okay, now I have to arrange these 3 equations and find this equation, right? So let me number it as 1, equation number 1, 2 and 3. Okay, so first you see I need half N2, right? So I'll multiply half to this equation. Okay, so if I multiply half to this equation, I will get, okay, let me write it again. 1 second. Okay, so what I'm doing, equation 2, okay, into half I'm doing. Okay, then for this equation, what you see, for this I need 3/2 Cl2, right? And I have only Cl2 in the third equation. I'll multiply 3/2 to this equation. Okay, so what I can do here, this plus, not plus, first let me write 2 equations. So I'll multiply 3/2 to equation number 3. Okay, and let us see what we are exactly getting after that. So I'll multiply here, I'll use different pen. So I'm multiplying 1/2 to equation number 2. So 1/2 of N2, 3/2 of H2, 2/2 of NH3. So that will get cancelled and I'll get only NH3, right? Now 3/2 to equation 3. So I will multiply 3/2 of H2, 3/2 of Cl2 and 3/2 of HCl, right? So that 2 will get cancelled, I'll get only 3HCl, right? So what will I get here? 3HCl. Clear? Now let us write these 2 equations together. So now if you see these 2 equations I got, right? What is the equation? Half N2 plus 3/2 H2 gives NH3, 3/2 H2 plus 3/2 Cl2 gives me 3HCl. Okay. Now what I'll do is I will subtract equation number 3 from equation number 2. Now why I am doing that? Now if you see, this is our required equation, right? Yeah, if you see, this is my required equation, and this equation there is no role of H2. Okay, so I want to cancel this H2. Okay, so what I'll do, I will subtract these 2 equations. So what I'm doing, 2 minus 3, equation 2 minus equation 3. So if I subtract this one, this one will get cancelled, right? So I will get half N2, okay, minus 3/2 Cl2, okay, then I am getting here 3HCl plus NH3. Okay, so this is equation number 4. Okay, now what I'll do, I'll add equation number 1 to equation number 4. Now if I just add these two, so what is equation number 1 here? You have NH3 plus 3Cl2, okay, that is giving you NCl3 plus 3HCl, okay. One second here you can see that if I am subtracting these two equation, right, I'll get minus NH3 minus 3HCl, okay. So here I'll correct it, this is little error I did here. So what it will be, NH3 minus 3HCl, okay. Now if I add these two equation, okay, what I'll get here, so you can see NH3 will get cancelled, 3HCl will get cancelled, and I am left with half N2, okay, plus 3 minus 3 by 2 is again 3 by 2, right. So I'll get 3 by 2 Cl2 will give me NCl3, okay. Half N2 plus 3 by 2 Cl2 is giving you NCl3. Now what you can do here, you can see, so what exactly we have done, we have got the required equation. So for this, what are the operations we did? First is we took half of what, we have taken half of N2. The second equation was multiplied by 1 by 2. So I need 1 by 2 of delta H2, right. So where we have that? We have that in all these equations, right. Okay, we cannot eliminate anything. Next I need 3 by 2 with all, right, with 3, this is also there. Now what I did with this one, these two equations were subtracted, right. So that is also there. Now after that, whatever we got, we added with delta H1, right. So that is why the correct answer for this question will be your option number A, okay. I think one second, minus delta H1 minus delta H by 2, yes. So that is what we have added. So option number A is the correct answer here, okay. Now here you see, after solving these two, this was minus, right, this 2 will be in the form of minus, and then we are adding it with minus delta H1, okay. So that is why the sign will not change here, okay. Fine. Next question number 9, the reaction in which delta H is greater than delta U. So if you see, delta H is equal to delta U plus delta NgRT, right. If I want delta H should be greater than delta U, then delta Ng should be negative, right. So you can see in which of these option delta Ng is negative. So what is the value of delta Ng? How to calculate delta Ng? Delta Ng should be number of gaseous moles of products minus number of gaseous moles of reactants, okay. So if you see here, delta Ng is 2 minus 1, 2 minus 1 plus 1, so that is 0 here. If you see here, it is delta Ng is, we have 1, that is positive 1, right. One second, we need what? Delta H should be greater than delta U, okay, sorry, one second, eraser, yeah. So delta H, okay, one second, let me explain once again this one. I did again a small mistake here. See, if you want delta H to be greater than delta U, that means what? This number delta Ng should be positive, means if you are adding these two numbers, then you are getting delta H, right. If you are adding, suppose this is 5, okay, if you are adding 2 plus 3, then you are getting 5, right. So if this is a positive number, then this one will be smaller than this one, right. But if I write, suppose this one has to be, then what I can say, that in this case, this is delta H will be greater than delta U, right, where it is 5 and it is 2. So I need this one as a positive number, okay, not negative. So now I hope this one will help you to understand whether it should be positive or negative. So now let us see the options. So here we have delta Ng is equal to positive 1, and here if you see, delta Ng is equal to 2 minus 4, that is minus 2, okay, and here if you see, delta Ng is equal to 1 minus 2 minus 1. So there is only one option with positive, so that is why option number B is the correct answer here. Next question number 10, in the following reaction, S plus 3 by 2 O2, okay, S plus 3 by 2 O2 is SO3, okay, and SO2 plus half O2 is also equal to SO3, right, and this is 2x and this is y. you need to find the equation for formation of SO2. Formation of SO2 will be S plus O2 giving you SO2, right? So these we need arrange these two equations to get this one, right? So what I can do, in this equation SO3 is not required, so we will try to cancel it. How can we cancel that? We will reverse this equation. Okay, if I reverse this equation, what I'll get, SO3 gives SO2 plus half O2. Okay, now this value will become minus y. Okay, now I am erasing this middle equation. Okay, and now you add both of these equations. Okay, you add these two equations now. SO3 will be cancelled. Okay, now this is S, 3 by 2 minus 1 by 2, that means O2 only, right? This minus 1 by 2 will come this side, 3 by 2 O2, right, minus 1 by 2 O2, that will be O2, right? So I'll get O2 giving you SO2. So what I have done, 2x minus y, that is option number D here. Okay, next question number 11. This is important question. The ratio of the heat liberated at 298 Kelvin from the combustion of 1 kg of coke and by burning water gas obtained from 1 kg of coke is. Assume the coke to be 100% carbon. Given enthalpies of combustion of C, CO and H2 are this, respectively, all at 298 Kelvin. Okay, so the question here is asking, you are burning 1 kg of coke, and from that coke you are also preparing water gas. Okay, and from that water gas you are burning it and you are getting some amount of heat, right? So what is the ratio of the heat liberated by burning directly 1 kg of coke, or by converting that to water gas and then burning it and then getting heat from that? Okay, see what I am telling. You have 1 kg of coke. Okay, you converted to it water gas. Water gas means what? CO plus H2, right? You converted it to water gas. Now you are burning this one directly, you will get some energy E1, and now after converting to this one you are again combusting it or burning it, you will get E2. So what is the ratio of E1 by E2? That is the question. I hope all of you are getting the question. You are having directly 1 kg of coke, you are combusting it, you got some amount of energy. You converted that coke to water gas, okay, and then that is undergoing combustion, you got E2. So what is the ratio of E1 by E2? That is what you need to calculate. So let us first see, okay, let us first calculate that how many, so you can see the combustion of C, CO and H2. So that means if you burn 1 mole of carbon, okay, if 1 mole of carbon is undergoing combustion, energy released is 393.5. But we have how much? 1 kg of carbon. So number of moles of carbon, given mass by molar mass, 1 kg means 1000 grams, molar mass is how much? You have 12, right, and gram per mole. So this one will give you 83.3 moles. Okay, so I can say that energy released from 1 kg of coke. Okay, energy released from 1 kg of coke. So that will be what? 83.3, it is 1 mole, into what is the number of, see, from 1 kg of carbon I am getting this much energy. So from 83.3 moles I will get this much into this much, right? So 83.3 into 393.5 kilojoule per mole. So let me write it with units. Okay, energy released from 1 kg of carbon, or I can say 1 kg of coke, that is from 1 mole I am getting 393.5 kilojoule per mole, okay, into 83.3 moles. Okay, so now I hope this part is clear, how much energy will be released by burning 1 kg of coke, right? Now you can see this mole will get cancelled, we will get the answer in units. Now see, and from this, if I am having 83.3 moles of carbon, okay, that many moles of water gas will also be produced, right, because water gas is nothing but CO and H2, right, same amount of carbon will be present. So I can say that if CO is burning, we are getting this much energy. If H2 is burning, we are getting this much energy. So I can say that total energy, total energy from 1 mole of water gas. Total energy from 1 mole of water gas, that will be from 1 mole of CO it is 285, from another 1 mole of H2 it is 285. So it is 285 plus 285, right? So how much I will get here? 570, 5 plus 5 10, 16, 70 to yeah, so I will get 570 kilojoule. But what is the total number of moles of water gas? Number of moles of water gas is 83.3 moles. Okay, next I'll get total energy released from 83.3 moles of water gas. Okay, so that is from 1 mole it is 570, so that is 570 into 83.3. Okay, so this is the total energy released here, this is the total energy released here. We need to take the ratio of E1 and E2, right? So E1 by E2 will be equal to 83.3 into 393.5, okay, divided by 83.3 into 570. Okay, so this we need to solve. Now you can see 393.5, right? So we can take somewhere around 393 divided by 570. So if you solve this, you can think it will be almost like not exactly half, right? So what I'll get here is 0. If you solve this, we'll be getting around 0.69 ratio 1. Okay, the correct answer for this question will be option number B here. Okay. Next question number 12. When 1 mole of H2SO4 is completely neutralized by sodium hydroxide, the heat liberated is 114.64 kilojoule. What is the enthalpy of neutralization? Now what is enthalpy of neutralization? When 1 mole of H plus reacts with 1 mole of OH minus to give 1 mole of water, the energy released here is called as enthalpy of neutralization. Okay. Now if I am reacting this one, H2SO4 plus NaOH, okay, so it will give you obviously salt and water, Na2SO4 plus H2O, right? Now if I balance this equation, you can see here I have to write 2 NaOH, now 2 H2, 2 H2, 2 sodium, 1 sulfur, 6 oxygen, and we have 6 oxygen. So I have to make this one also 6 oxygen. Now it is balanced. Now here from this I will get 2 moles of H plus, and from this I will get 2 moles of OH minus, right? So the energy released during this reaction is 114.64. But here how many moles of H plus and OH minus are reacting? 2 moles. But what is enthalpy of neutralization? 1 mole of H plus and 1 mole of OH minus should react. So when 2 moles of H plus, right, plus 2 moles of OH minus has reacted, I got how much energy here? 114.64. To calculate for 1 mole, what I can do? Just we need to divided by 2, so that will be around 57.32, right? But now again heat liberated, right, that means it is negative, right? The value here is minus 114.64. Enthalpy of neutralization is an exothermic process, so that's why it will be minus 57.32. Option number C is the correct answer here. Okay. Next question number 13. What will be the amount of heat released by burning 10 liter of methane under standard conditions? 10 liter of methane we are burning, okay, given heat of formation of CH4, CO2 and H2O are these values respectively. Okay, so let us see first combustion of methane. What is the equation? You will have CH4 plus O2 gives you CO2 plus H2O. Okay, now to balance, right, whenever you write the combustion equation, make sure that the product, or the compound which is undergoing combustion should always be 1 mole. Okay, this should be 1 mole. Now if I want to balance here, it should be 2. Now I have here 2 oxygen to 4 oxygen, so I will make it 2O2. So carbon 1, 4 hydrogen, 4 hydrogen, 4 oxygen, 4 oxygen. It is now balanced, right? Now what I'll write? Now I'll write the enthalpy of this reaction. Okay, how much? We have first, I'll write the formula, enthalpy of carbon dioxide, right, plus 2 times enthalpy of water minus oxygen, it is what? Elemental state, its enthalpy of formation is 0, minus enthalpy of CH4. Okay. Now if you see this one, carbon dioxide is, so let me write down the values separately. CH4 value is 76.2, right, minus 76.2. Then you have CO2, its value is minus 398.8. okay, and then you have water is minus 241.6. So I will substitute here these values. For carbon dioxide it is minus 398.8, right, plus 2 times of delta H of water is 241.6 minus 241.6, okay, minus you have enthalpy of CH4, that is minus 76.2. okay. Now what you have to do? You have to do this calculation. Okay, you have to do all the multiplication and the calculation. I will also do with you so that we can do the calculation together and get the answer. Okay, so first what is there? 2 into 241.6. So first let me multiply 241.6 into 2. So that is 2 6 are 12, 2 1s are 2 plus 1 3, 2 4s are 8, 2 2s are 4. Okay, so I got here minus 483 and I am adding this to 398.8, right. So that will be 8 plus 2 10, we have 1 here, then 8 plus 3, 8 plus 1 9, 10 11 12, 1 9 plus 1 10, 8 18, 4 3 7 plus 1 8. Okay, so let me check the calculation. Yes, so I got 882. This is minus 882, right? This value I got is minus 882. Then I have this side plus 76.2, means I have to subtract this one, right? So 76.2. If I subtract this, I'll get 10 minus 2, 8. Then I have this one 11 minus 6. So I'll get 5, right? Then this is 0, this is 8. So let me check the calculation once again. 7 plus 1, 8. Yes, minus 805.8. So this one is minus 805.8. Okay, so now what I got information after doing this calculation is, if I burn 1 mole of methane, then I am getting how much energy? So from 1 mole of methane, okay, energy I am receiving, or energy that is liberated, is minus 805.8 if the calculations are correct. Okay, so let us see. But the question is not asking about 1 mole of methane. In the question 10 liters of methane are burnt. If I want to calculate 10 liters of methane and I want to convert it into moles, number of moles of methane will be given volume, right, given volume by molar volume. That means given volume is how much? 10 liters divided by 22.4 liters, okay, per mole. So that will be 10 by 22.4 moles. Okay, now if I calculate total energy released, right. Now you see, for 1 mole this much was the energy released and I have this many moles, so I have to calculate this one. So minus 805.8 into 10 divided by 22.4. So I can write it like 80580 divided by 22.224, right. Can I write like this? Just I cancelled 8058 by 2 divided by 10. So now if you see, this will be somewhere around, you can see 400, or like if I multiply 224, which number it should be there, you can check this. Okay, if you calculate this, you will be getting around 359.7. So correct answer will be option number C here. Okay, so if you want to check, let us divide and see also. Okay, so let us divide this one and check. So if I want to divide this with 8058 with so we can see the options that we have. This 2 we can definitely ignore because it is somewhere 4 times we know, right, near to 4 times, but we have option 398.9. So we can just check the first 2 digits and then we can decide the answer, right. So I can do here is 80580 divided by 224, right. So if I take 4 4s are 16, 4 2s are 8, 4, so I'll get somewhere around 4, so it will be 3, 3 4s are 12, then I have 3 2s are 6 plus 1 7, 3 2s are 6, 9 5 minus 2 3, then I'll get 10 minus 7 3, 7 minus 6 1, right. Now if I see 1 3 3 8, now what I should take, whether it should go 9 or 5. So if I take 9, it is something, it will come more than 8, this value, right. So it has to be 5. 5 4s are 20, 5 2s are 10, 12, 5 2s are 10 plus 1 11. So I got 3 5, so that is why correct answer has to be option number C here. Okay. Next question number 14, which thermochemical process is shown by the following figure? This diagram is there in your NCERT book. This is nothing but Hess's law, right? Hess's law says that delta HR will be equal to H1, H2 and H3. So that is option number C. Okay. Next question number 15, this is also important question here. Bond enthalpies of A2, B2 and AB are in the ratio of 2:1:1. A2, B2 and AB. 2:1:2. Okay. If bond enthalpy of formation of AB is minus 100 kilojoule per mole, formation of enthalpy of AB is minus 100 kilojoule per mole, the bond enthalpy of B2 is. Okay. So now let us consider this is 2x, this is as x and this is as 2x. Okay. Now I can write the formation like this: A2 plus B2, right, gives you 2AB. Okay. No need to put equilibrium sign here. I can just write the normal way. Okay. Now if you remember, delta H of a reaction in terms of bond enthalpy is bond enthalpy of products minus bond enthalpy of reactants minus bond enthalpy of products, right. So I can write down this delta H of reaction will be equal to bond enthalpy of A2 plus bond enthalpy of B2 minus 2 times of bond enthalpy of AB. Okay. Now here we need to see that what is the enthalpy of reaction. The question is saying that if 1 mole of AB is formed, then 100 kilojoule energy will be released. But in this question or in this equation, I have formed 2 moles of AB. For 1 mole 100 energy is released, so for 2 moles 200 energy will be released. So that means minus 200, okay, is equal to what is A2 value? A2 I have taken 2x here, right, and B2 value is x, okay, minus of AB value is 2x, right. So I will get 3x minus 4x, right, and that is equal to minus x is equal to minus 200. So I can say x is equal to 200. Can check here, x is equal to 200. So they are asking you for B2 and B2 value is x only, so that has to be 200, option number C. Okay. Next question number 16. If the bond energies of HH, Br, Br and HBr are these values, then respectively delta H for the reaction is. Similarly, we already know what is the formula. Delta H of the reaction is always equal to bond enthalpy of reactants minus bond enthalpy of products. Now, if I have bond enthalpy of reactants, what is the reaction? H2 and Br2, right? I have to add for H2 and Br2. So let me write down the values first. For H2 it is 433, okay, plus Br2 it is 192, okay, and for HBr it is 364. Okay. So now if I see bond enthalpy of H2 is how much? 433, right? Okay. Plus reactant, another reactant is Br2. Bond enthalpy of Br2 is 192. Okay. Minus bond enthalpy of product, that is HBr. So it is 2 times of 364. Now I have to solve this. Okay. So if I just add this one, 3 plus 2, 5, 9, 10, 11, 12, 4, 5, 6. 625 minus 2 times of 2 4s are 8, 2 6 are 12, 2 3s are 6, plus 1 7, 28. So I'll get the answer in terms of minus, and if I subtract 8 minus 5 is 3, 2 minus 2 is 0, 7 minus 6 is 1, minus 103. Option number D is the correct answer here, right? Direct formula based question. Next, question number 7, lattice enthalpy of NaCl is 788 and hydration enthalpy is minus 784. Enthalpy of solution is. So if you remember the formula here, enthalpy of solution will be equal to lattice enthalpy, okay, plus hydration enthalpy. Okay, so what is lattice enthalpy? Lattice enthalpy is 788, okay, and what is hydration enthalpy? Minus 784. Now if I solve this, it will be 4 kilojoule per mole. Okay, so the correct answer for this question will be option number B here. Next, question number 18, for 1 mole of NaCl the lattice enthalpy is. So this is your Born-Haber cycle. So if you remember, for Born-Haber cycle, this one I can write that delta H formation of NaCl. Okay, delta H formation of NaCl is equal to delta H sublimation. Now see, you can see this diagram. First, what has happened? Sodium solid is converted to sodium gas. So this energy is your sublimation enthalpy. Then sodium gas here is converted to sodium plus. So this is your ionization energy. Then from, if you see from this step to this step, Cl2, half Cl2 molecule is converted to Cl gas, and this is your breaking of chlorine molecule, or I can say bond dissociation enthalpy. I got Na plus gas, I need to get Cl minus gas, right? So if I add if I see from here to here, Cl is converted to Cl minus, so energy released in this process is this one. So now I have got Na plus gas and Cl minus gas to give you NaCl solid. So this is what? This is your lattice enthalpy. Whatever energy released here will be your lattice enthalpy. Now the same thing we can be also written in form, the formation enthalpy of NaCl will be sodium solid plus half chlorine gas, because the elements are in their native state in this particular equation, right? So I can write the enthalpy also. This equation should be equal to these all equations, right? So I can say the enthalpy of formation of NaCl will be equal to first sublimation enthalpy plus ionization enthalpy. Next, what I have here, I have this is gone ionization enthalpy. Then we have bond dissociation enthalpy, right? Delta H of bond dissociation enthalpy. Next we have, so here I need to multiply half, this is per mole, this much energy is required, so this is half mole, right? Then we have delta H of electron gain enthalpy, okay. Next I have lattice enthalpy, okay. Now you can substitute all these values here, okay. So what I can see, what is the formation enthalpy? Minus 411.2, that is equal to sublimation enthalpy 108.4, okay. Ionization energy 495.6, okay. Then I have bond dissociation enthalpy 1 by 2 of 121, okay, plus electron gain enthalpy, if I see, it is minus 348.6, okay. Then I have lattice enthalpy that I have to calculate, okay. Now if you solve these all values, you will find that the X value will be around minus 788 kilojoule per mole, okay. Fine. Next, question number 19, conversion of oxygen to ozone, okay. Oxygen to ozone, gas. Now you see, here there is more number of gaseous molecules, here there is less number of gaseous molecules. So I can say that the entropy is decreasing, right? If entropy decreases, it is a non-spontaneous reaction, right? So that is why it is non-spontaneous at all temperatures, okay. It is independent of temperature, it is a non-spontaneous process because the number of gaseous molecules are decreasing, the randomness is decreasing, okay. Next, question number 20, for the following gas phase reaction PCl5 giving you PCl3 and Cl2, which of the following conditions are correct? Okay. Now if you see, this is what we are breaking PCl5, right? Endothermic reaction, decomposition reaction. So endothermic means delta H will be positive. We have two options with delta H positive, we can eliminate these two. Next, if you see here what is happening, here there is only one gaseous molecule, here there are two gaseous molecules, right? That means what? Number of gaseous molecules have increased, entropy will increase, delta S will be greater than 0. Here delta is negative, so we can eliminate this option. Here delta S is positive, option number D will be the correct answer here. Next question number 21. A process is spontaneous at a given temperature if. So if you see, delta G is equal to delta H minus T delta S. At any given temperature, if we want that the reaction should be spontaneous, then delta H has to be negative, delta S has to be positive. Now if you if you see, it will be delta H minus T delta S, right? And addition of two negative numbers will give you a negative number, and delta G will finally be negative, and the reaction will be spontaneous. So for that, delta H should be negative, delta S should be positive. Option number C is the correct answer. A similar question was asked in 2016 also. A reaction is spontaneous at all temperatures when delta H is negative, delta S is positive. Option A. Okay. Next, when the same quantity of heat is absorbed by a system at two different temperatures T1 and T2, such as T1 is greater than T2, the change in entropy are delta S1 and delta respectively then. Okay. If you see the formula for delta S is equal to Q by T. Okay. Now what happens if there are two systems, okay, A and B. This is at T1, this is at T2, T1 is greater than T2. You provided same amount of heat Q and Q here, right? So this is constant. This is delta S1 and this is delta S2. Okay. Now if you see what is the relation between delta S and T. If this temperature is very high, this one will be less, right? So if T1 is greater than T2, that means if T1 is greater than T2, then I can say that delta S1, okay, will be less than delta S2, right? Now see, here more temperature means entropy change will be less. How I can write it in the form of equation? See, okay, now see, we have, what is the relation I can write down? Delta S1, okay, is proportional to 1 by T1 and delta S2 is proportional to 1 by T2. Okay. Now what we know that T1 is greater than T2, right? So if I divide this two equation, I'll get delta S1 by delta S2 will be proportional to T1 by T1, okay, divided by 1 by T2, I can write down T2 by T1. Now we know that T1 is greater than T2. Right, that means this value, if this value T1 is greater than T2, that means what? This value is less than 1. So I can write this as T2 is, because T1 is greater than T2, then I can write T2 by T1 will be less than 1. So this value is what? Less than 1. So I can write delta S1 by delta S2 is less than 1. That means delta S1 is less than delta S2. Okay, no need to do these many mathematics, you can easily understand. If temperature is higher, delta S value will be lower. Okay, so what is this one? This is the correct answer, option number D here. Next question number 24, correct statement regarding entropy. So at absolute zero temperature, that means 0 Kelvin, okay, the entropy of a perfectly crystalline solid is 0. Yes, this is a correct statement here. At absolute zero temperature, the entropy of a perfectly crystalline substance, no, it is a solid, it has to be solid, okay. So this is also is positive, no, it is also 0 here. At absolute zero temperature, the entropy of all crystalline substances is 0, no, not all, only perfectly crystalline solids, okay. So that is why these statements are wrong. Then 0 degree Celsius, that is 0 Kelvin. Next question number 25, the entropy change for a non-spontaneous reaction is 140 kilojoule per mole at 298 Kelvin. The reaction is, this is also very tricky question. Now see, it is saying that non-spontaneous means the reaction is not happening by its own. You have to provide energy for that, right? If you want to provide energy for that, then definitely it has to be a endothermic reaction. So option number D is the correct answer here, okay. Okay, or you can also see like this, if I am writing like this, delta G is equal to delta H minus T delta S, okay, and we have been given with T delta S value, it is, this one is positive, okay, this is delta H minus this T delta S has to be 140 into 298, right? So definitely this one, if this one is also becoming a negative value, okay, if this one is negative, then two negative numbers cannot give you a positive number, right? So definitely this has to be a positive number. Now if this is a positive, it has to be endothermic, okay. Next question number 26, a reaction has both delta H and delta S negative, the rate of the reaction. So if you have delta G is equal to delta H minus T delta S and both are negative, that means minus delta H plus, this will, if this is negative, minus minus will become plus, right? Now what will happen? How will the reaction change? So if I want this overall number to be negative, then the temperature should be less, okay. Like for example, see, suppose we have minus 5 plus, okay, I'll take some minus 50 plus T into delta S, okay. Now if this temperature is very high, for example delta S value is let me take as 10, okay. So minus 50 plus T into 10, okay. If temperature is very high, for example temperature is 200, okay, temperature is 200, then what will happen? I'll get minus 50 plus 200 into 10, that is 2000. So overall I'll get delta G as a positive value, but I need that the delta G should be negative for the reaction to occur. So if I take a lesser temperature, like suppose I take T equal to 4, okay. If T is 4 degrees Celsius, then what I'll get? 50 minus 40, I'll get minus 10. So reaction can proceed by when the temperature should be less, okay. So reaction will increase with the decrease in temperature. Option number C is the correct answer here, okay. Next question number 27, which of the following statements regarding Gibbs energy is correct? Okay, delta G is negative, the process is non-spontaneous. No, if delta G is negative, process is spontaneous, right? Delta G is positive, the process is spontaneous. No, delta G should be negative for this process to be spontaneous. Yes, option number C is the correct answer here. Next question number 28, the equilibrium constant of a reaction is 0.008 at 298 Kelvin. The standard free energy change of the reaction at the same temperature is. So if you remember this formula, delta G is equal to minus 2.303 into R into T log of K, right? This is there. Now if I want to calculate delta G, that will be equal to minus 2.303, okay. R value is what? 8.314, okay. Temperature value is 298, okay, into log of K is 0.008, okay. Clear this one? Done. Now if I solve this, I'll be getting around plus 11.92 kilojoule, okay. That is option number A here. You can check the calculation and do this. Question number 29, the standard enthalpy of decomposition of N2O4 to NO2 is 58.04. So delta H value is 58.04 kilojoule, okay. And standard entropy delta S is 176.7 joule per Kelvin. You can see the difference in units, okay. Therefore the standard Gibbs free energy change, so you have to calculate the Gibbs free energy at temperature is 25 degrees Celsius, means 298 Kelvin, okay. So now if I solve this, what is the equation we have? Delta G is equal to delta H minus T delta S. What is delta H value? Delta H is 58.04 kilojoule, so if it is converted to joule, it will be 58040, minus T is 298, right, and delta S is 176.7, okay. So now here the game was where you may do mistake, that you should not forget to change the units. So if I solve this, we will be getting around 5, it will be a negative number, so 5.39 or 5 so all the options are very close, so you have to do the calculation correctly. So let us do it. Let me make it 300, okay, just for because we don't have much difference, number should be same, but we should know where the decimal comes. So let me make it 300. So 176.7 into 300, if I do, what I'll get here? 3 7s are 21, 3 6s are 18, 19, 20, 3 7s are 21, 22, 23, 3 1s are 3, 4, 5, okay, 5301 will I get, and then these two zeros are there, and I'll put a decimal here. So I'm getting 53010, okay, 53010, okay. and I have to subtract it from 58040, right? So I'll get 0, 4 minus 1 3, 8 minus 3 5, okay, 5030 I am getting. Okay, next we have to convert it into, this is in terms of joules, right? So if I do kilojoule, I'll get 5.03 kilojoule, right? So 5.03, it will be kilojoule, option number C. Okay, there will be some calculation error because of this approximation, but I know it will be a positive number and 5 point something. Okay, next is question number 30. An endothermic reaction is found to have positive entropy change. Okay, so endothermic reaction is there, positive entropy change is there. So delta G is equal to delta H minus T delta S, right? So this is also positive and this is also positive. Okay, so now if you see, the reaction will be, okay, so reaction will be possible if both are positive, that, but I want overall it has to be negative, then this T value should be very high, so that I get a very negative, very big negative number from this positive number, and the addition of that two will give you a negative number, right? Again, for example, if you have taken here 50, okay, minus T into delta S, okay, and let delta S be, let me take delta S value as 20 for example. Okay, so now if I take very high temperature, let the temperature is 100 degrees Celsius or 100, that means I will get 50 minus 100 into 220, right? That is 50 minus 2000, right? Now this one has to be a negative number then, so this T should be very high for the process to be spontaneous. Okay, possible at high temperature, option number A. If temperature is less, so for example, if the temperature is 2 degree, okay, then I'll get 50 minus 2 into 20, that will give you 50 minus 40, that is equal to plus 10. Reaction will not occur if the delta G is positive. Okay, so that's all 30 questions we have discussed. Now here I have written the topics and the number of questions asked in different topics that I could find. So you can see in types of process, you got 2 questions, work done you got 3 questions, first law only 1 question, enthalpy you can see 7 questions were from enthalpy, Hess's law 1 question, bond enthalpy 2 questions, lattice enthalpy 2 questions, spontaneity there were 4 questions, entropy 3 questions, Gibbs free energy 5 questions. So if you want to skip this chapter also, make sure that you are revising these concepts: work done, enthalpy, bond enthalpy, spontaneity, entropy and Gibbs free energy. If you are doing this much also, you will be able to solve the question. Okay, so if you don't have time, make sure that you practice at least these topics. Okay, fine. So that's all student. In this class we have done with the chapter thermodynamics. The next chapter we are moving towards is your equilibrium. So I hope you are finding these lectures helpful in your KCET preparation, and yes, if that is correct, do not forget to subscribe the channel. See you soon in the next class.